Hassler here. I'm going to work through the 1.4 vocabulary and then the 1.4 examples and ideas so that we understand what is happening in this unit. And if you have questions, make sure that you check in with your teacher. So we have one vocabulary word for 1.4, and it is an explicit rule. And an explicit rule is a general formula. Gives a general formula for a pattern. So we give a general rule for a pattern. And then this rule can be used to find any term in a sequence. And just a reminder, when I say sequence, I mean a list of numbers. Okay, so for example, if I tell you that I have the general rule 3n minus 5, and I say create a list of the first 4 terms, that's what I want to do, okay? And what I like to do when I create my list is you can either use a table or I like to draw like these lines. So a space for my first term, my second term, my third term, my fourth term. Right, I'm just going to label this. This would be my first number in my list and my second number in my list and the third number in my list and the fourth number in my list. What that means is when I say the first number, second number, third number, fourth number, I have this n in my formula, and this n represents the position in my list. So n equals position in the list. So if I want to find the first number in my list, what that means is I have to take this formula and I'm going to replace the n with 1. And I'm going to write 3 times 1 minus 5 because n represents the position in the list, and I'm trying to find the number in the first spot. And then I'm going to do that calculation. 3 times 1 is 3, minus 5 is negative 2, so I get negative 2. Similar idea, if I want to find the second number in the list, that means my n is 2. And I'm kind of out of space, so I'll do it down here. I'm going to do 3 times 2 minus 5. 3 times 2 is 6, minus 5 is 1. And if I want to find the third number in the list, then that means my n is 3. And I go through this process again, right? I'm going to do 3 times 3 minus 5. And 3 times 3 is 9, minus 5 is 4. And if I want to find the fourth number in my list, I'm going to say n is 4. So I'm going to do 3 times 4 minus 5. So every time I'm just replacing that n with the position in the list. And 3 times 4 is 12, and 12 minus 5 is 7. Okay, so I'm creating that list by replacing n with the position associated with the number I'm trying to find. All right, so we're going to take this a step further. We're going to take a look at some examples, and here we go. It says, look at the pattern below. So again, I have this picture, and it looks like this picture keeps changing. And so I'm going to go ahead and start counting. I have 4 squares in this first figure. And I have 1, 2, 3, 4, 5, 6, 7 squares in the second figure. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares in the third figure. And so I want to know what's happening in figure 4. And based on this pattern, I'm guessing, because it looks like I'm adding 3 each time, I'm guessing that this should have 13 squares. But I want to draw a picture of that. So in each of these pictures, I've got 1, 2, 3 squares at the bottom. I'm going to make 3 squares at the bottom. And in each picture, it looks like, I have 1 square on the right, and then 2 squares on the right, and then 3 squares on the right. So I'm thinking on the right side, I should have 4 squares since I have figure 4. And then let's see, in the middle, I had 2, and then in figure 2, I had 4, and in figure 3, I had 6. So in figure 4, I should have 8. Okay, so I have a total of 13. Okay. So again, we mentioned that I'm changing by 3 each time. So I just want to remind ourselves that we have this common difference of 3, which really means that we are working with an arithmetic pattern here, an arithmetic sequence. And so because this is arithmetic, there's a certain way that I'm able to write a rule. And so let's just, give ourselves some direction here. And we're going to write an explicit rule, a formula, to find the number of squares in figure N. Okay. So I'm going to write a rule to find the number of squares in figure N. Okay. So when I go to write this rule, because it's arithmetic, we're going to be in this form blank N and then either plus or minus, depending on what's happening, blank. So again, just like we said at the top, my N is going to be the position in the list, or in this case, my figure number, right? First figure, second figure, third figure, etc. Okay. The number that goes here is going to be my common difference. If I'm changing by 3 for every figure, and I just noticed that I had this little mistake here. I wrote plus 13. It should be plus 3 because I have an answer, or a total of 13. Okay. If I'm adding 3 to create every figure, and I keep adding 3 over and over and over again, repeated addition is actually just multiplication. And so we're going to multiply my common difference, that change of 3, by n. I'm adding 3 over and over and over again. And so addition is just repeated, multiplication is just repeated addition. I'm repeating this add 3. So I'm going to write that as multiplication. For every change in position, I'm changing by 3. And then I got to figure out what number goes here. So there's a couple ways I can do that. One way is I can say, hey, I need to know what number I add or subtract to get the value in my list. That's one way to think about it. So we're gonna come over here and we're gonna test some values. Okay, so we're gonna say, hey, in my first figure, I had 4. So it means I'm gonna say 3 times 1 plus something gives me 4. Right? If I have my first figure, that means that n is 1. And let's think about this. If I did 3 times 1, that's 3. 3 plus 1 gives me 4. So plus 1 would work here. And I want to test the second figure. Second figure means that n is 2. And in the second figure, I had 7. So that means I should be able to do 3 times my second figure plus some number should get me 7. Let's test it. So 3 times 2 is 6. Hey, 6 plus 1 gives me 7. So this plus 1 seems reasonable. What that means is over here in my formula, I'm not actually going to have the minus. I'm going to have just the plus 1. 3n plus 1 ends up being my formula. And I'm checking over here on the side to test and see, okay, what do I need to add or subtract so that I can get that number in my list? I'm always going to have a common difference times n. That common difference is my repeated addition. But what number do I need to add or subtract so that I can make this list work? That's not the only way to think about this, though. And so I'm going to give you one more way to think about this. What we're going to do is we're actually going to work backwards. So I'm going to come up here to figure 1. I'm going to say, hey, what if I go backwards? And if I go backwards, I get myself to figure 0. And if I work backwards, I'm actually subtracting 3, right? Because going this direction, I'm adding 3. So to go backwards, I have to subtract 3. And if I do 4 minus 3, I take away 3 blocks. I actually start with just 1 block. 1. And it turns out that 1, that number in the 0 spot, matches the number it's going to take for me to complete my formula. So this process works only for arithmetic. The green part of my formula, you can do 2 different ways. You can either start testing numbers and find what you need to add or subtract in order to get the number in your list, or you can work backwards and find the 0th term in your list. And that would be the number that goes in that last spot. So your job is going to be to work on the 1.4 practice and to ask questions. And for some of the problems, the ones that are arithmetic, you're going to use this idea to help you write that explicit formula.